Alright, okay, so as you're viewing this, I actually drew this beforehand so we don't waste too much time. But here I'm going to give you a few numbers, okay, and then you can compare it to the way the elevator setup has been done. Okay, so here the assumption is we're going up, okay. In this case, acceleration is 1 meter per second squared, so we're speeding up. In this case, we're going up, but acceleration is negative 1 meter per second squared, so meaning we are slowing down. In this one, we're going in the down direction, so the elevator is going down, okay, and we're initially speeding up with 1 meter per second squared, and then here we're going down and we're slowing down at 1 meter per second squared, okay? So in all these situations, okay, remember that the equations are pretty much the same. So when we're considering up, remember that this was F net equal to mass times acceleration from Newton's second law, which if you viewed the other videos, you'll notice that since we're going up, we must write Fn, because it's in the positive direction, up, minus W, okay? And now all we do is we just use the numbers to figure out what is our apparent weight, okay? So this is what we want to know. So there's two cases. One case, I'm not going to do everything, but I'll just substitute it in. So mass is equal to 50, acceleration is equal to 1, okay? And W, okay, so here I'm going to write it because it doesn't change, okay, is actually equal to 490. And I'm omitting significant figures here, okay, because so you can assume that, you know, there's 2 sig figs or something, but it's more about the setup of the question. So what we have is, okay, we have this, which is 50 equal to Fn minus 490, okay, and we can solve now for Fn, and that is just algebra, okay? So this is with the case of speeding up. Notice that this is positive. In the second case, okay, when you redo this, so meaning MA is equal to, it's still the same thing, it's Fn minus W, except now what you'll notice is this will be negative 1, because we're slowing down here, and the rest is the same. Okay, so that's the only difference that you have between speeding up and slowing down. Okay, and it's important to have Fn minus W because we're going in the up direction. Okay, so Fn has to be positive minus W, which is in the opposite direction of movement. Okay, so those are the two cases. When you're going down, okay, then again we still have the same equation. F net is equal to MA, except now when we're summing up our vectors of forces, well, recall from the video that now we have to write W minus Fn, which is the opposite of what we wrote here. And the reason for that is, okay, because I choose the direction of positivity, okay, so positive direction, always to be in the direction of movement. So my movement is down, so I'm going to assume that down is positive, and W is in that same direction. So here it will be positive. Fn, on the other hand, is in the opposite direction of movement. So what I do is I make it negative. And now the two cases are identical again. So you would write 50, that's the mass. Okay, if you are speeding up, 490 for our weight, it doesn't change. And that's it. Okay, and now you solve for Fn. On the other case, okay, here you're going to write 50 minus 1 equal to 490 minus Fn, but since you are slowing down here, this has to be negative. And that's the only difference. So you have all 4 situations that can occur. Speeding up, slowing down, either going up, and speeding up, slowing down if you're going down. Okay? And the numbers, of course, can change, but the process is identical. Okay, so I hope that you find this useful. You can just rerun this as many times as you like. Okay, good luck, because you'll definitely see this sometimes down the line.